Hey guys, so today we are going to look into solving a system of equations by graphing it. So again, we're going to utilize Desmos, but first we need to figure out what are we looking for. So some of our notes here, we had a note sheet in class in regards to what are we looking for when we're asking you for a solution to the system of equations. So when we're looking for a solution, we are finding the point where the two lines cross or intersect. That is our mission, is to find where do these lines cross or intersect one another. And so our point is going to have to be written as an x, comma, y, a location, a point, not our rise over run. So how do you find the solution? Well, first, we're literally going to graph it. Sometimes the graph will already be there. So first you're going to graph it in Desmos, and then you're going to locate where do they cross or touch. And that'll reveal the x, comma, y, the point of which is our solution to our system of equations. And so let's take a look here. There's two ways that you can go by solving by graphing based on what's given to you. So if you're given the graph, all we need to do is find the point where my lines cross or touch. So if we're given two equations, the first thing you need to do is graph it, and specifically we'll graph them in Desmos. Number two is find the point where they cross or intersect. And then the third is write down that intersection point. That is our solution to the system. So let's actually get some practice going on in here, guys. So if I look at number one here, where do these two lines cross? And I'm hoping you're looking right here. So how far over from zero is that happening? So from zero, that's to the left 2, so negative 2. And it's down from 0 2 spaces as well. So our solution is negative 2 comma negative 2. As we look at the middle guy here, we have a solution where they cross, and it is over 1, up nothing. So 1 comma 0 is our solution to that system. So as we look at the third one here, we are over positive 4 to the right, and we are up 1 as our solution to our system. Now remember, the solution to your system is a point on the graph where the two lines cross or touch. So let's take a look at the fourth one here. I have a solution of over 3 and up 3. So 3 comma 3 is my intersection point or my solution. And on this next one here, we are over to the left 4, so negative 4, and we are up 1. Uh-oh, SpaghettiOs. Taking a look at the last one here, are these lines ever going to touch or cross? And if they do not cross, we have a special phrase we use. So if they do not cross at all, am I ever going to intersect? And the answer is no, I'm never going to have a point where I intersect at. So this is what we call no solution. And when that happens, guys, it's when my lines literally never cross each other. So be cautious of that. That is a special case. You may want to make a note. All right. This next part, I want you to actually graph the system with me. So we're going to graph it in Desmos. So when we graph these lines in Desmos, they look a little bit something like this. And so your mission is to find where does my blue line, the 2x minus 1, and my green line of x plus 1 cross or meet. Now the cool part about Desmos is you can literally hover over that point or click on that point, and it will reveal its location. So we know where this point is. It's at 2, 3 is our solution. So 2, 3 is our solution to our system here. Now we could graph it by hand, but it's not necessary when we already have this really cool tool that will already graph it for us. All right, so let's try another one. Now, when you go to put this one into Desmos, guys, the second equation is a fraction. So when you go to type this in, you got to use your divide button, which is your question mark button on your Chromebooks. So you're going to hit that button and it'll give you the bar, and then make sure you put the X beside it. And then we'll finish that up. And we are looking where my purple line and my black line meet, and it looks like they cross each other right there at -3, 1. So we have our intersection point, which is our solution, which is -3, 1. All right, now let's take a look at the last one and graph. Okay, so when we go to graph these in Desmos, I want you to take a look at something. Notice I don't have 2 lines on my graph, but I can ungraph them. So you can see what's going on here. So this first one in standard form is this red line. And then if I reintroduce my blue line, notice it literally verbatim lays over top of my red line. So that means if one line is on top of the other, how many times are you guys going to touch? Or how many times will this line continue to have the same points where they cross or meet? Well, these guys are literally on top of each other, which means that because my lines go on infinitely and I only see one line, it's because they are literally one on top of the other. Or some of us may call that overlapping lines, because that makes sense since they are overlapping each other. One is on top of the other. We, in fact, have a phrase for this, and this is what we call infinite number of solutions. And why that is because our lines literally are touching the entire length of your line. So entire length of your line means that I have an infinite number of solutions. So let's summarize how many different types of solutions I can have in a system. The most common and the easiest is literally one specific point where you meet and greet. So right here at 3, 1 there, okay? The one that you guys really liked was our no solution because we had 2 lines that will never touch or never cross. So if we don't cross each other, it is no solution. And then we had the one that gets a little tricky. And the tricky one is when we have an infinite number, when we overlap or we always touch, or we have one line drawn. So keep that in mind. And I want you guys to try the practice Excel sheet there for number 36. And then you also have an at-home assignment number 36 as well, which is a Google slide. Good luck, guys. It is very visual. Use Desmos.